Hi there, I'm Hao, and this is just another video of me solving random numerical problem. So we have to have a graph problem today. So we need to find the number of provinces. There are n cities, right, in an n by n matrix. And then some cities are connected, some cities are not. And if A is connected to B, right, city A and city B, and city B is connected to C, which means A and C are connected. And the province, a group of city, right, that is directly or indirectly connected, right? And we just have to return the number of provinces that we found. Um, so we have a disconnected matrix here, right, representing whether the city is connected or not, right? So if we have n city, uh, so if we have I and j here, right, it's equal to 1, which means city I and the city j are connected, right? And ij is equal to ji, right? If A is connected to B, which means B is connected to A. It is a bidirectional. Okay, so if we have n city, right, let's say n is 3, which means we have the city from 0, 1, and 2, right? Right, we can go from like 1 to 3, right? 1 to n, or you can go from 0 to n minus 1. Doesn't really matter here. So let's just like this 0, 1, and 2. Okay. So we need to keep track of the city we have visited, right? So whenever we visit a city, right? If the city hasn't been visited, then we just have to completely explore the city, right? Which means we are exploring all of the city, all of the other city that is connected to the city we are currently looking at, right? And as we exploring the province, right? Uh, we just have to keep track of the visited city. Right? The two, right? 0, 0, and 1, 1, and 2, 2, right? Are just the city by itself, right? But just let us do it step by step. So we just have to iterate over each city, right? And then completely explore it. And every time we found a new city, then we increment the province, right? Province equal to 0, right? So we start at city 0, right? So the province given to 1, right? So now we found a city that we have not never been visited. And now we just have to completely explore the province, right? Explore all of the connection of the city that is connected to the current city, right? So we gonna iterate, we're gonna check like 0, 0, right? 0, 1, and 0, 2, right? Because there are only 3 cities, right? So 0 and 0, right? So 0 is already in the visited set, right? So we ignore and we check 1, right? So 0 and 1, right? City 0 and city 1, right, is connected because the value here is 1, right? So we add 1 to here. Okay, same for 2, right? Um, 2 is not yet in the visitor set, right? So we're gonna check 2, city 2, and city 0 and city 2 are not connected, right? Because the value is here 0, right? So we stop. Okay. So now it is what we currently have, right? 1, 2, 0. Okay. Now we are checking the next city, city 1, right? City 1 is already in the set, right? So we're not gonna explore the province of city 1 because city 0 is already connected to city 1 earlier, right? Which means city 1 is part of the previous province, right? The province consists of 2 cities, 0 and 1. 0, the 1 is already part of the previous province, so that is in a visited set. So we just don't do anything, right? So we go to the next city, city 2. Right? City 2 is not yet in a visited set, so we add 2 here, right? and increment the province, of course. Okay, now we just have to explore the province, right, to city 2. So we can uh, look at 0, 2, 1, and 2, 2, right? So 2, 0 here. So it's not connected, right? CD0 and CD2 is not connected, right? CD0 and sorry, CD1 and 2 are not connected, right? And then CD2 and 2 are connected, but 2 is already in the set, right? So we just don't do anything. So this we what we have at the end, right? Two province. Okay, so the time complexity would be O of n square, right? Because we need to look at every single node in the graph. And the space complexity would be of n, right? Because we need to keep track of the visited city, right? Where n is the number of cities. Okay, so let's code this up. We can use depth first search or breadth first search to solve this when we explore the province. And I'm just gonna use depth first search in this case, right? So we have a number of cities, right, equal to disconnected line, right? Because they are n CD, right? And it is an n by n matrix, so it's just gonna be the lines. And we need to count the province, right? And then return the province at the end. Okay. So we need to iterate through every single city and explore it. Okay. So if the city hasn't been visited, not so if visited if visited doesn't have a city, right? Which means we haven't visited the city yet. Then we want to increment the province, right? And then completely explore the province, or in other words, completely explore the city connection, right? Okay. So let's create a hyperfunction. So DFS here. So we're gonna look at the city, right? So whenever we explore a city, right, which is a part of the province, right, we want to add it to the visited set. Right? And we need to iterate through every single city. Let's call this one order city. Right. So if the city is connected, right? If the current city is connected to the other city, right, and the other city hasn't been visited, then we will keep exploring, right? Right. So again, whenever we just iterate through every single city, right? If the city hasn't been visited, then it means we found a province, right? So we completely explore that province, right? So whichever city we saw, we're gonna add it to the visitor set, right? And we need to check to see if this city is connected to all other cities, right? Right. If it is connected, right, and then the other city hasn't been visited, then we're gonna keep exploring that city, right, for the province, right? And we are exploring it by adding it into the visitor set. Okay, so let's try that, and it worked. Thank you for watching.